Saxon Algebra 1, Lesson 39. We're going to start with something that sounds so flippin' hard. Trichotomy axiom. What the heck? Sounds like some sort of surgery, emergency surgery on your throat, right? On your trachea. But it's not that. It does not involve emergency medical procedures. It is a really, really simple rule. For any two numbers that are real numbers, exactly one of these things is true. Either A is greater than B, A is equal to B, or A is less than B. Whoa, did I just rock your world? That's what the trichotomy axiom is. 3 parts, right? There are 3 different relationships that can exist between numbers, but only one can be true. Huh, all right. Good to know. Make sure you write that down. You don't need to write it in your book necessarily. I'll remind you next year. But when you see how we use it, you'll see it's totally common sense. We're going to use it in a variation on the symbols we've been talking about that are called negated inequalities. Write that down. And I'll tell you how it works. Let's just jump to the problem. It's always easier to explain it in a problem. It says, draw a number line and graph the solution of, and then it gives me a little expression. That's what we've been doing, right? We did that in what, 37? Yeah, last time we did ratios. So we're gonna draw a picture on a number line using the symbols that we've been using. But look, this time, John uses a weird symbol. That, my friends, is called a negated inequality. It should be more of like a straight line. It almost looks like it's curving, but it's not. It's like this. It's like slashing it out. What that means, we need the trichotomy axiom to make sense of it. That means that what we're being told is that x is not less than 2, right? We're saying cross that out. We know that's not true. So what does that mean? What we want to do right away is rewrite this as one of the inequalities that we know, not a negated inequality. So that's how we use this, is we say, okay, well, if it's not less than, then x is either greater than or it could be equal to 2. So that tells us what to graph. And then we go here and we draw in the 2 and we say, oh yeah, we want to include 2, so that needs to be solid. And then it's greater than, so we want every value that goes that way. Does that make sense? (39.2), there's just one more of these. Write both an inequality and a negated inequality that describe this graph. So let me draw you the picture. John gives us this. He's got 3, he's got an open circle, and he's got this way. Okay? So what that means is he wants us to write it first using whichever of these are true, and then writing it again using whatever of these are not true with a slash through it. So let's figure out what is true first. This is x. It's less than, because we're choosing the values that go this way to the left, so that means lesser. 3. And now the big question is, should we include 3 in this solution or not? We see the open circle and we go, okay, the open circle means don't include 3.00000000. So this is the correct answer. This is the inequality that describes this. So now what we do, so that's this one, right? So now we say these two go together like that, right? We can put 2 of the 3 together. So we put those 2 together and say it's not that. Does that make sense? These are the 3 conditions that it can be. If we know it's this one, then we know it's not the other 2. If we wanted to, the negated equality of this one is just 1. So our negated equality can have two of them, the equal sign in one of the inequalities, or it can just be one. We can do it either way. Okay, this is the right answer. Yay. We're going to deal more with those. Most students find them somewhat entertaining. Okay, and then part C for this lesson, folded page, we're going to do a little bit more in the ratio department. More ratios. Advanced ratios. Whoa. Pretty cool. Okay, again, John does not use my tic-tac-toe board method. And let me just read you the problem and then I'll tell you what's different. They're a step more complicated than last time. The ratio of red marbles to blue marbles is 5-7. If there are 156 marbles in the bag, how many marbles are red? Okay. I drew 3 rows this time. Please draw with me. I drew 3 rows. What do you suppose that's about? Well, I'll tell you in a minute. This is still ratio and actual. Let's read the story again. I'll give you a second to catch up. I have a feeling I went fast. The ratio of red marbles, I'll just write it out this time, to blue marbles is 5-7. If there are 156 marbles in the bag, 156 marbles in the bag, that includes the reds and the blues. So where do we write 156? It doesn't relate to either one. Oh, here's the trick. Total. We're now going to put a total, and we know that the actual number of marbles in the bag totals 156. Okay? So we have to add this new line, which is super easy to do because look, if we want to fill in over here, the ratio total, we just add those, right? 12. Super easy. We always have to do that, almost always. Sometimes, 9 times out of 10, we'll get the two of numbers in the individual ratio and then we'll add them together. Every once in a while, John will play a little trick on us and give us the total and one of the individuals, and we have to go backwards to find the other one. But most of the time, he's going to do it like this. He'll tell us this number, this number, this number, make us figure out that one, and then he'll tell us which one of these he wants to know. How many marbles are red? So the red is where we put the X. Now, that leaves us with the blues. We don't have much information about the blues, nor are we asked to find it. So what we can do is just lightly cross that out, because we're not going to need that row right now. And these 2 rows give us the information we need to create our fractions. So we're going to go 5/12 equals X over 156. Okay? So it still works just as easily once we squiggle out the row and say, never mind, blues, we don't need your help anymore. All right, cross multiply. 5 times 156 equals X times 12, divide by 12. That's cool, there's our X by itself. Now, again, we just need to try and reduce this. 5 and 12 have nothing to say to each other. What about this 156? Okay, this is how my brain does it. I know that 12 times 12 equals 144. So if I keep one of those 12s, that will help me. 144, how many 12s are left if we subtract 144? Oh, there's one more 12. Right? So this gives me the 156 that I'm looking for, and this tells me that it's 13 times 12. So when I go to cancel this and this, it's 13. And so my final answer is that X equals, and where am I? 5 times 13. My denominators went to 1, right? That was at 1. and that is 65, and that represents the number of reds. Some people like to get fancy and write 65 red marbles in the bag. That is not necessary for me, nor for John. Just keep it short and sweet. 65 reds, and again, I really like that. Now, if we wanted to be super fancy, we could figure out how many blues now, couldn't we? Because 156 minus 65 would have to be it, and that would be what? 91? Yes. So this, we could fill it in and write 91 right there. John does not ask us to do that, so we don't have to, but it's nice to know that if he ever decides to get crazy and ask us a problem like that, we know how to do it. This was 39.3, by the way. And we just have one more, 39.4. The ratio of oh my gosh, help me speak, please. The ratio of fish to crabs in the sea cave was 13:4. Okay, I'm imagining like a whole, not so much Finding Nemo, but a Little Mermaid scenario, because Sebastian's the crab, right? In Little Mermaid. Maybe it's a mashup of the two. Okay, so I'm gonna create 3, from now on, we're just gonna automatically create 3 lines in our ratio problems, ratio, actual, because we're gonna do fish to crabs, always in the same order as the story, fish to crabs, total. The ratio of fish to crabs in the sea cave was 13:4. If there were 119 fish and crabs in the sea cave, so that's the actual, how many were the fish? It seems like in all of these problems, John's asking us about the top row. It doesn't matter. He can ask us about the first or the second, and we'll set the problem up exactly the same. We filled in the information. We put X for the question. All we need to do now is add our total for the ratio side, squiggle out the row we don't need, and set up our fraction. 13 over 17 equals X over 119. These numbers look hideous, don't they? But I have great faith that it's going to work out. Cross multiply. 119 times 13 equals 17X. And then divide by 17. I am going to pray that 17 is going to go into 119. And this is what my brain is doing now. My brain is going, oh, I don't know my 17 times tables. And long division isn't going to help that much because we're just going to have to figure it out in the long division format. It's not going to break the number down for us. So this is what I think. I've got a 7 and I need it to turn into a 9. So 7 times what equals something that ends in a 9? 17 times 7 is what I suspect, because 7 times 7 will give me the 49. All right, so I use my units place or ones place digits to kind of make an estimate. So this becomes 7 to 7 is 49. 7 times 1 is 7 plus 4, 11. So it worked out, right? So I did that by thinking 7 times what will end in a 9? 7 times 7 is 49. So those cancel. I get a 1 down here. I get a 7 up here. This canceled. So now to get my answer, I just have to multiply 7 times 13, that's 70 plus 21, so that's 91 fish in the sea cave. And that's correct. Oh, I forgot to write fish. This is why I like to put it in the table, because even if you forget to write fish in your answer, you've kind of written it by saying the actual number of fish is 91. So you kind of cover your answer and communicate information just by filling that number in the block, the blank. It's not a block, it's a blank. It could be a block blank or blank block. All right, that's lesson 39. A nice little mashup of ratios and inequalities, which have been our topics lately. Now we're gonna go into 40 on our next lesson and just do some hardcore algebra. It's gonna be fun. See you in lesson 40.